Alright, good afternoon, ladies and gentlemen. What you're looking at here, I've kind of got the camera just sitting here today. What you're looking at is our new OmniScan, or one of our new OmniScan ultrasonic units here. We've got it basically operating right now in the regular conventional ultrasonics mode. If we jumped here, this would take us over to phased array, which we'll be able to see the difference just very, very quickly. And this is just a little intro is all it is. So if we were just looking for phased array here, as this thing's changing, we're going to see the difference right now, not much. But if you look here, you see a focal law, calibration, group wizard, stuff like that. That's going to give us different views of what we're actually looking at here. We want to see, just real quick, I'm just going to push these buttons and kind of make it run through here, just so we can get a image. Whoops, let's make it actually happen here. Alright, next. This doesn't make us any difference. We just want to see the baby view versus the regular A-scan view. So, if we were doing phased array, this would be phased array. We're not there yet, but just so you can see what phased array is actually going to look like, there it is. Alright, now back to regular UT here. Make that switch back over. We're not going to save that setup. What I've got right here is just a standard step wedge block, 1 inch, 3/4, a half, and then 1/4 down there at the bottom. Okay, just going to slap a little coupling down on there. Okay, and as you know, coupling just displaces the air and all. So we're going to set our range here to 1 inch. Okay, simple terms. We've got a huge thing happening on the screen here. Bring the gain down. Gain's no more than volume of the energy. Okay, or amount of energy, I guess we could say. We got a 1 inch. Okay, we got 0 dB gain, longitudinal wave. There's a longitudinal velocity of steel. 0.2319, that's inches per microsecond. If we converted that out, that'd be 231,900 inches per second. That's actually 10 to the 6th there. So 0.2319 times 10 to the 6th. So we've got our coupling on our 1 inch block here. Let's just slap it down on here and see what happens. Okay, we really don't see a lot going on because we can't see out past the 1 inch. So we need to take our range and go about 1.2 on this scope so we can see the edge of it. If you see here, 0.2, 3, 4, 5, 6, 7, 8, 9, my hand's probably in the way. There's 1 inch, so let's do that again. 2, 3, 4, 5, 6, 7, 8, 9. All tenths of an inch. Okay, here's 1 inch, here's 1.1, 1.2 is out there on the end. So if you're looking at just a general screen, 0 to 100%, full screen width, 0 to 100% full screen height. Alright, so we're just looking at our 1 inch signal here. Let's just get that calibrated as closely as possible. We're going to do that with range and delay, but since we already know what our range is, we're going to do that with velocity and delay. Okay, so I'm going to take my velocity here, and I'm just going to type in 2300 even, see what that does. That pushes it, whoops, I pushed the wrong thing, 0.2300 even. That's better. That pushes it pretty close to 1 inch. Let's go a little bit less. Let's go whoops, push it again here, 0.2290. See what happens. Getting closer. You can see that's getting ready to line up on the 1 inch there. Let's get a little closer here. Be zoomed way in for you. So I'm going to change that again. I'm going to go 0.228. This is going to mess it all up here. Let's just clear it all out if we can. Nope. Alright, so now it's way off again, so 0.22. As you can see here, my hands aren't working with my brain. 0.228. That's better. Now we've stretched our range out. Okay, we don't want that. So we're starting to mess this thing way up. Alright, there we go. That's better. There's our range. Let's enter. Okay, we're getting really close to the 1 inch there. So I'm going to hit that one more time and do this. 0.227. That's about as close as we're going to get it. So let's back out. Get to the whole view again. There's the whole view one more time. Let's go to 3/4 of an inch now. Coming up pretty close to 0.75. we're pretty close to a half. Okay, we're not necessarily perfect. 25, 50, 75, and 1 inch. So let's actually push all this over a little bit with our delay. We're going to push the whole thing over with the delay, and we're going to look at what's returned. We're going to push everything over with a delay, and we're going to adjust the back signal here with our velocity. So let's take our velocity and go 0.2275. That pushes everything over just a little bit. So now we're 25%, 50%, 75%, 100%. And this signal doesn't look that great. So let's see if we can clean it up a little bit. I was in the right one. So here's our pulsar menu. Okay, we're in pulse echo. We have a 5 megahertz frequency. We only have 50 volts here. If we run that thing to 100 volts, we've got big, huge signals, and we don't want to do that. So let's turn that down to low. You see it brings that back down. Let's go to receiver here. We have no filter. Let's put that on a 5 megahertz filter. That cleans it up a little bit. Let's turn the filter on. Now we've cleaned it up a bunch. We've gotten rid of a lot of that, but what happens there was we filtered out a lot of information. For what we're doing now, that's going to be fine, but sometimes we might want that filter to be off. Okay, you can kind of see what happens there, how it cleans that signal up and back. Alright, types of waveforms now. If we're looking at full wave, which is what we have here, that's the whole full wave right there. Let's go half wave negative. We can see how that's completely changed the signal. Let's go half wave positive. Okay, there it's changed again. Now if we jam both of those together, we've got full wave. Okay, and for some reason it's not letting us see the RF signal right now. Not that that's a bad thing, it's just not letting us see that. Okay, we got a blinking gate over here. You can see we've got some information up here that's going to come later in life. We're just looking at basic information right now. Okay, so let's go back over here, right at a half and 1 inch. Okay, and you can see how that signal's taking it a while to actually come together. That's because it's averaged. It's filtered. Okay, we're actually a little above 1 inch there. We're going to take that and call it good for now. 3/4 of an inch, half an inch, and then here, I know you can't really see the block, but what I'm doing here is just this. Okay, here's my block. There's my 1 inch. Here's my 3/4. Here's my half. Here's my 1/4. Okay, and you can see the signals come up in the back. So when I'm talking there, you see what's going on. Now, one thing I want to show you, there's my 1 inch thickness. Okay, got a little bit of trash over here. I'm bringing in an IIW block of the same thickness. It's steel. Okay, here's, whoops, sorry. Here's an IIW block. Okay, kind of see the whole thing here. We're just going to look at the 1 inch thickness. Okay, we've got a huge difference between this signal here and this signal here. Okay, here we're on 1 inch. Let's take this out now to a range. Alright, here's our range. Let's go out to about 2.2 inches. Here we're right at 1 inch, here we're right at 2 inch. And again, the calibration's a little off, which we could clean that up a little bit here with our delay. And we're looking, okay, basic information again, we're looking at where the signal breaks the baseline. Okay, that's good information. I'd like to see a little bit here. You see all this trash that's back here now. Okay, we've got some trash that's building up. I'm just moving this around. I'm on my little step wedge here. I'm going to put that over here. So you can see I'm on the 1 inch thickness for my step wedge. Okay, there it is. I'm on my 1 inch thickness. And I've got this trash back off over here. Okay, I am going to take that, put it on my IIW block now. And I've gotten rid of a lot of that trash over here. Okay, it's not all gone, but most of it's gone. And what happened was, I had beam spread in here. So if I had beam spread in here, okay, I've got this 5 megahertz half-inch diameter transducer. I put it on there. I've got beam spread in there, just like we've looked at in UT1. And that beam spread is what I'm seeing right here. Okay, so when I go back to my IIW block, my beam spread is better because there's a lot more room for that sound to spread out in there, and it goes away from the transducer rather than coming right back to it. So if we take a look at that, that's kind of where we're headed this week. Just basic calibration stuff. You can see a couple of those. And then as we press on through weeks week 2 and on, we're going to actually look at measuring stuff, measuring thicknesses, looking at gates, and we're going to be talking about shear wave and actual application stuff. So, any questions, feel free to email me, call me, no big deal. Just one last thing right here, just so you can see this. If you see these numbers here, 1.05, we've got a 73. This isn't mattering to us right now, but we've got another 1.05 right here. That's just basic thickness. That flashing gate is what's telling us this thickness here. So if we take that away, it says ND, meaning not defined. Slam her back down on there. That's about 1 inch. Let's just see without moving anything. We got about 1.5 because we've actually gone through that gate. So we're going to take that gate just real fast. I know we're kind of jumping ahead here, but this isn't going to hurt you to see. We're going to take this gate, we're going to move it over here, just so we look at one part of this. Okay, I moved it over. Still looks like we've got a 1.5 flashing in there. So let's change all these gates now to where they're all in the same spot. Right there. Okay, let's look at this guy. Take him. Where'd you go? Where'd you go? Where'd you go? There we go. Right there. Okay, so now I'm going to go back to my A gate, which is the red blinking one. I'm going to bring him down a little bit. So now I'm just covering one signal here. I'm not messing with this signal. I'm just looking at this one, and I've got all 3 gates over it. That doesn't make us any difference, but what we're doing here is just making sure that one of them is working for us. So let's get the rest of them out of here. Okay, B gate. I'm just going to move it way off over here. Okay, I gate. I'm going to do that as well. So now it's not affecting us at all. Okay, 0.812, 0.812. That's telling me our thickness. Okay, right now I'm on a 3/4 of an inch, so I'm a little off, but that's all calibration stuff. So if we went through and looked at calibration, we could get this right to where we want it. We're not there yet, but we could. So just quite simply, I'm going to toss another video up on calibration, getting this thing rocking and rolling on actual good calibration. But this is just a good video to get us started so you can see what's going on. Alright, any questions? Like I said again, just email me or call me.